Hey guys, welcome to CPM 3. This is Module 1, Lesson 6. This is actually your last lesson in Module 1. So, last lesson, very long lesson. Last lesson, we learned how to graph lines by making your T-chart, where you put 3 points in and then graph those 3 points. Today we're going to learn a second way. There's going to be a total of 3, but we're going to learn a second way today by graphing them by their intercepts. This method is usually, in general, a lot easier than what we did in the last lesson, lesson 5. So, the point where the graph crosses the x-axis, this is called your x-intercept. So then likewise, where it crosses the y-axis is called your y-intercept. So you can kind of see here from your picture, your x-intercept is where it crosses this x-axis right here. And your y-intercept is where this graph is crossing the y-axis, which happens to be right here. So I'm going to go over this helpful hint here in just a second. That's going to make more sense if we actually do an example first. So example 1, identify the intercepts. So we have x-intercept and a y-intercept. Now, sometimes you're going to have more than one. Sometimes you're not going to have one. So it just kind of depends. But on this one here, here's your x-axis. So your x-axis is going horizontally. So where is this blue line crossing your x-axis? That is right here. And so this is x equals -3. So when you write this as an ordered pair, because x equals -3, remember your ordered pair is usually x comma y. So this number goes in for the x. Since x equals -3, we get -3 for the x, and then 0 for your y. So then your y-intercept, where is this line crossing your y-axis? Y, it's right here. This point is at y equals 2. So same thing but opposite of this one here. If my y equals 2, then my 2 goes in place of my y coordinate, and then you put a 0 in for your x. And so that is what this little helpful hint is kind of telling you. A lot of times it gets confusing. Does the 0 go for the y or does it go for the x? And so it says right here, notice that for the y-intercept, the x value is 0. And for the x-intercept, the y value is 0. So it's kind of opposite. So if x equals 3, your x is 3 in that ordered pair. If your y equals 2, your y equals 2 in that ordered pair. Let's turn the page and let's do a couple more of these examples. So on this next one here, we need to find our x-intercept. So where is this graph crossing my x-axis? Well, this one actually has 2 right here. So this one is x equals -4. And this one here is x equals -1. So you have 2 separate ordered pairs. This first one for my -4 means that I've got -4 in place of my x coordinate. In place of y, we've got 0. We also have y is -1. So for my x, it's -1, and we put the 0 in for the y. So then, find the y-intercept. Where is this graph crossing my y-axis? And this is at y equals a +1. So what is that as an ordered pair? Well, the y is 1, so you've got 1 in place for your y coordinate. So then your x coordinate is 0. Okay, same thing here. Your x-intercept, where is this graph crossing my x-axis? It's crossing right here. So this is at x equals 2. So because x is 2, you've got 2 in place of your x coordinate, and so for your y is 0. So then for your y-intercept, where is this graph crossing my y-axis? Well, it's not. So this is one of those cases where you've got none. And then on our last example, where is this graph crossing my x-axis? Right here at x equals -1, and here at x equals 3. So for my x-axis, we've got 2 again. So because x is -1, -1 for your x, comma 0, x is 3, so in place of your x, 3, comma 0. And then for your y-intercept, where is this crossing my y-axis? It's crossing here. At y equals 2, and crossing here at y equals -1. So my y-intercept, y is -1. So in place of your y coordinate is where that -1 goes. So 0 for your x. And when y is 2, that means you've got 2 for your y, 0 for your x. So you can kind of see here that you can get no intercept, you can get multiple intercepts, you can get just one intercept. It varies depending on what the graph is. So now that we can kind of recognize these, now the main sort of part of this lesson is graphing lines by their intercepts. So, given an equation of a line, to find the x-intercept, if there is any, let y equal 0, solve for x. So vice versa. Given the equation of a line, to find a y-intercept, if there is one, let x equal 0, solve for y. So example 2, graph each linear equation by finding and plotting its intercepts. So let's find an x-intercept first. When you find an x-intercept, you're going to let y equal 0, just like if you look at all of these here, when you have your x-intercept, what is y? Y is always 0, and so that's why we're letting y equal 0 to solve this. So, in place of this y, we're putting a 0. So I've got x minus 0 equals 5. Well, x minus 0 is just x, right? If you have 10 minus 0, that's 10. That's your original thing right there. So you got x equals 5. So that is my x-intercept. Now, let's get in the habit of writing these as an ordered pair. So my ordered pair then would be x is 5, and we plugged in 0 for y, so 0. So you can go ahead and plot that. Let's remember OU. We need to go over side to side 5, then up or down 0. So from the origin, we're going 1, 2, 3, 4, 1, 2, 3, 4, 5, positive, 0, up or down. So now find your y-intercept. So when you find your y-intercept, we're going to let x equals 0, solve for y. Same thing. Look at all of these here. What is my x in all of these? They're all 0. So that's why we're substituting in 0 for this. So in place of this x, we got 0. So 0 minus y equals 5. That 0 can just kind of leave us, but we do have a negative in front of that y. So negative y equals 5. Now, if you can go straight to just y equals negative 5, please do so. If not, to get that negative away from that y, you either need to multiply or divide by by a negative 1 to get rid of it. Because now negative over negative is positive, so now I've got that y. So then 5 divided by negative 1 is negative 5. So that's my y-intercept. Again, let's get good at writing these as an ordered pair. So my ordered pair is 0, since that's what we plugged in for x. But more importantly, my y equals negative 5. So along my y-axis, we need to go down 5. 1, 2, 3, 4, 5. So here is my line. Okay, we got 2 more examples like this. B, we got 2x plus 4y equals 8. So find your x, find your y. When I find my x-intercept, we're letting y equal 0. So in place of this y, we're plugging in 0. So 2x plus 4 times 0 equals 8. Well, 4 times 0 is 0. That cancels out. So I've got 2x equals 8. Divide both sides by 2. And I get x equals 4. Now, as an ordered pair, x is 4. So 4 comma. We put in a 0 for y. So 0. So on your x-axis, go 1, 2, 3, 4. And then for your y-intercept, now I'm plugging in a 0 for my x. So we've got 2 times 0 plus 4y equals 8. Again, 0 times anything cancels out. So I'm left with 4y equals 8. Divide both sides by 4. And we get y equals 2. And so again, as an ordered pair, we put in a 0 for x. So 0 comma, and then my y is 2. So we're going to go 1, 2 up on my y. And so here is my line. And let's try one more time. So same thing. To find my x-intercept, we need to plug in 0 for y. You're plugging in 0 for the other thing you're wanting to solve for. So negative 6x minus 3 times 0 equals 18. 0 times anything is 0. That's why these are so easy. Negative 6 then equals 18. Divide by negative 6. And we get x equals a negative 3. So as an ordered pair, x is negative 3. And we plugged in a 0 for y. So on my x, I'm going to go 1, 2, 3 over in the negative direction. So then find your y-intercept. So that means I'm plugging in a 0 for x. So 6 times 0 minus 3y equals 18. 0 times anything cancels. So we're left with negative 3y equals 18. divide by -3, and we get y is -6. So as an ordered pair, we plugged in 0 for x, and my y is -6. So on my y-axis, we're going down 1, 2, 3, 4, 5, 6. Okay, that's a pretty good line. That arrow sucks, but that's a good line. All right, objective 3, we need to identify and graph vertical and horizontal lines. So if it is a vertical line, that means you have x equals a constant. If you have a horizontal line, that means you have y equals a constant. You can memorize these if you want. You can also make that little T-chart where if it says like x equals 3, then you've got 3, 3, 3, 0, 1, 2. Pick any number for these y's. Or if it's something like y equals 5, then you put 5, 5, 5, and then 0, 1, 4. Put any numbers you want for here. Okay, so that's one option. You can memorize these if you'd like. Okay, that's another option. But now that we know more about x and y intercepts, let's just use that to graph on this next page. So it says identify the type of equation, horizontal or vertical, and then graph. So again, you can flip over to that last page and memorize it. I think the easiest thing to do is actually graph it, and then you look at the graph and see if it's vertical or horizontal. So if you got x equals -3, that's the same way that we had like right here. X equals 4, so we went along that x-axis to 4. Do the exact same thing here. If I've got x equals -3 along my x-axis going this way, we're going to go to the left negative, 1, 2, 3. Because there's not a y in this equation, that means it's never touching this y-axis. So it is this line right here. Now, a lot of times what happens is when you graph this at 1, 2, 3, you say this is my line, you want to graph it with the x-axis, but that's not true because it can't touch this y-axis if there's not a y there. So just find that equation and go through it. So now that I'm looking at it, I can see that this is a vertical line. So now that I know x equals a number is vertical, I should already know that that means that y equals a number is horizontal. But still, go along your y-axis. Okay, going this way. +2. Same thing. Because it says y equals, a lot of times because this is your y-axis, you guys want to draw a line through that y-axis and say this is your line. But because there is no x in this, that means it can never touch this line here, so it's parallel to it. So your line is horizontal. Now C, all you got to do is solve this. So how do you get x by itself? Subtract your 3 over. So I'm going to get x equals 2 for my equation. Because it's x equals, I know that makes this vertical. And now graph it. So on your x-axis, which goes this way, go 1, 2. And that needs to go parallel to that y-axis. So there's your line. right. We're going to finish this lesson off with 3 word problems. Example 4 says the production supervisor at a particular office products company finds that it takes 3 hours to manufacture a particular office chair and 4 hours to manufacture a desk or computer chair. A total of 1,200 hours is available. Is available to produce office chairs and desks of this style. A linear equation that models this situation is 3x plus 4y equals 1,200, where x represents the number of chairs produced and y is the number of desks manufactured. Complete the ordered solution of 0, something of this equation. Describe the manufacturing situation that corresponds with this solution. So the first part's easy. Complete the ordered pair. So if this is my ordered pair, that means x is 0. We're solving for y. So my equation is 3x plus 4y. And I'm plugging in 0 for x, so 3 times 0. 0 times anything goes away. So I've got 4y equals 1,200. Divide by your 4. And we get y to be 300. So when I complete that ordered pair, it is now 0, 300. So that's the first part. Now we have to describe the situation that's corresponding with the solution. I'm just going to give you a little hint. This is a test question. Here's what I'm looking for when you give me the answer to this. There are 3 different components and I need to know about all 3. I need to know how many hours total there are. And I need to know how many chairs and how many desks we are making. So in this ordered pair, if I have 0 for my x, what does that mean? Well, I underlined this thing for a reason. I don't want to go back and reread this and find important information. It says right here that x represents the number of chairs. So I need to make a note that we've got no chairs. So if a company makes no chairs, okay, what does this represent here? This represents the number of desks. We can make 300 chairs. Let's say it, or they. Oh, sorry, 300 desks. Since y is desks. Okay, but I also need to know about this magic number here. If a company makes no chairs, they can make 300 desks in 1,200 hours. Those are the 3 things I need to know about. I need to know about the chairs, the desks, and how much time I've got total. Last page, we got 2 more problems. Example 5 says, since 2003, admissions at the movie theaters have been declining. the number of people, Y, and that's in billions, who go to the movie theaters each year can be estimated by the equation, it's nice and bold there, where X represents the number of years since 2003. Not just years, but years since 2003. So, A wants me to find the x-intercept of this equation. So when I find the x-intercept, that means we're plugging in a 0 for y. So I've got 0 equals negative 0.025x plus 1.8. So solve this. I know they're decimals, but treat it the exact same. Opposite of a plus 1.85 is to subtract 1.85. Cancels over here. And I have negative 1.85 equals negative 0.025x. So now divide by negative 0.25. And we get 74 equals x. Now, it doesn't really say to write this as an ordered pair. So if it doesn't say to write it as an ordered pair, that is acceptable. But let's just keep getting practice at it. So your ordered pair would be 74, 0. So part B wants to know, what does this mean? So we got 74 for the x. What does x represent? X represents the number of years since 2003. So because it is since then, that means after it. So we got 2003 plus my 74. That means we are in year 2077. What does this 0 here mean? 0 is the number of people. Number of people what? That go to movie theaters. So in 2077, that 0 means no one will go to movie theaters anymore. Okay, what's important with this one though is you can't just tell me in 74 years, because are you talking about in 74 years from now, in 74 years from what year? So that's why you've got to tell me 2077. All right, in example 6, you will find something like this in your My Math Lab homework. So that's why this one here is included. A new car worth $48,000 is depreciating in value by $8,000 per year. The mathematical model, which describes the car's value Y, in dollars, let's do that. Let's say Y is in dollars. After X years is this equation here. So we have a part A through D. A says to find the x-intercept, describe what that means. So, to find the x-intercept, it means you're plugging in a 0 for y. So I've got 0 equals negative 8,000x plus 48,000. So get x by itself, we're going to subtract this 48,000 over. So I get negative 48,000 equals negative 8,000x. Divide by a negative 8,000. And we get x to be 6. Now again, this doesn't say write as an ordered pair, so this is acceptable, but that would be 6, 0. And so what does this mean? What does x represent? X is years. I'm going to run out of room on this one. I'll go over here. In 6 years, what does this represent? Your dollars. So in 6 years, a $40,000 car is worth, you could put $0, but essentially it's worth nothing. Okay, so B, find the y-intercept. Y-intercept, we're going to let x equal 0. So that means we've got y equals negative 8,000 times 0 plus 48,000. Well, 0 times anything goes away. So we've got y equals 48,000. Again, it doesn't say as an ordered pair, so that's acceptable. But that would be 0, 48,000. So, describe what this means. 0 represents years. So, before you drive off the lot, what does this mean here? This is your how much your car is worth. So a car is worth, or we'll say the car. The car is worth 48,000 buckaroos. Part C, use the intercepts to graph the equation. Because x and y are both non-negative, limit your graph to quadrant 1 because of its boundaries. So what that means is, if you don't draw this, but if this is your graph here, and you have your time down here, and the money, the worth here, this car, even though technically it could cost you money, you could have to change the oil or fix the engine, fix this, fix that, it's technically never going to cost you money. So I don't need all of it. It's not going to ever be worth, owe you anything. Now we're not going to get into, well, if you take out this loan and this is only, then you're under on the, okay, we're not going into all of that. I'm just saying this car is never going to cost anybody anything. Same thing on time. If this is 1 year, 2 year, 3 year, 4 year, we can't go back in time. So there's no such thing as negative years. So because we're only dealing with positive things, that's what it means by non-negative, then we are only looking at quadrant 1 here. So this is my graph. And so this doesn't have to be perfect, okay? But if this is my time, we need to go over somewhere over here to 6. That's my x-intercept. And if this is how much my car is worth, we need to be up here somewhere on 40. $48,000. And so before, like the other ones where you had the line going infinitely in both directions, there's no arrow on this one. The car starts at this much in year 0, and in 6 years it's going to be worth nothing. So it stops and starts right there. Okay, so quadrant 1. So then part D says use the graph to estimate the car's value after 3 years. Okay, so you can use this. You know, year 3 is somewhere here. So what is that? What's that worth? Your graph on my math lab is just as bad as this one is here. So the graph doesn't help you. Just use your equation and plug in. If we're after 3 years, years is X, that means my X here is 3. So just plug in 3 for X. So we've got Y equals negative 8,000 times 3 plus 48,000. Now again, you can do this part by part if you want. Negative 8,000 times 3 is negative 2,400. No. Let's add another 0. Let's try 24,000. Then plus 48,000. That means my Y here is 24,000. So what is my car's worth? The car is worth $24,000 after 3 years. It doesn't really say to explain all that, but good rule of thumb, rule problem, word answer. So the car is worth $24,000 after 3 years. All right, that's all I got for this lesson. Let me know if you have any questions, rewind, and pause.